Cast-on technique. A new and interesting alternative in the field of combined dental prosthetics is the cast-on technique. Casting one metal onto another usually results in a fusion of the two. For example, a crown cast onto a prefabricated precision attachment. The cast-on technique, however, avoids this bond. Here, the objective is not only to fabricate an exact secondary part, that is, a negative of the primary, but also to be able to separate the two after casting. This process introduces interesting possibilities for use in dental prosthetics. Above all, the dental technician can achieve greater precision in less time. The conventional method is to duplicate the master model, whereby the primary segments are also reproduced in investment material. On this duplicate model, the entire secondary structure is waxed up, invested and cast. The results are acceptable. Nevertheless, an exact fit can't be guaranteed. Precious time is lost in trimming and fitting the removable secondary structure. Using the cast-on technique, the secondary structure may be cast directly onto the milled crowns of the abutment teeth. These primary parts remain attached to the duplicate model, and the secondary framework can be waxed up directly onto these attachments. After casting, the primary and secondary parts are separated. The result is an absolutely exact fit. Trimming is unnecessary. A basic requirement to success in the cast-on technique is the problem-free separation of the primary crowns and secondary framework after casting. This is guaranteed through the use of Rhymanium CD. This highly corrosion-resistant cobalt chrome porcelain bonding alloy possesses ideal oxide production characteristics which practically predetermine it for use in the cast-on technique. Rhymanium CD is easy to process due to its reduced hardness. The parallel surfaces of the primary attachments must be milled precisely, since undercuts would make separation impossible. The cast-on technique has many uses. The anchor band crown is very helpful as a molar attachment, since it's easy to activate. The channel shoulder or the channel shoulder pin attachments are useful for premolars. If the friction surface is large enough, pins and other supplementary attachments may be omitted. An anterior may need an interlock or an individually sculpted rod connector to increase retentive surface. An attachment may also be used to achieve the necessary retention. Since the parallel milling of the telescope crown provides too much retentive friction and taper crowns don't have enough, these two types of attachments should not be used with the cast-on technique. The following case will illustrate the main points that have to be taken into account with the cast-on technique. A Kennedy Class II with an edentulous space between 24 and 27. The following teeth have been cut and prepared for crowning: 12, 13, 23, 24 and 27. The following constructions are planned: channel shoulder attachment around 13 with interlock. An individual connection rod is added to increase the retentive surface. A channel shoulder attachment is also planned for 24. In addition, a pin will be used to increase retentive friction. An anchor band crown is planned for the last molar. A palatal bar is suitable as a transversal connector. The waxed up crowns should be carefully scraped or milled. This is also true for the groove where the pin will be placed. Accuracy and precision at this stage will save a great deal of time while milling the metal. The use of Castorit Super C investment material assures a smooth surface and exact fit with all non-precious alloys. Romanium CD may be cast with a high-frequency centrifuge or with a blowtorch.